Hello, my name is Chad Marnie and I'm an application engineer here at Ally PLM Solutions. I'd like to welcome you to another session of NXCAM Lunch Bytes. Today we're going to look at 3D contour machining in NXCAM. We have several of you on the line with us today, so you'll be in listen-only mode for the session. If you have any questions after the session, you can email those to me at chad.varney@allyplm.com. I want to remind you that we have all of our Lunch Byte replays available on our website, so you can check those out at www.allyplm.com. We also have a section on there where you can give us your suggestions for future Lunch Byte topics. Today we're going to look at 3D contour machining in NXCAM. Contour machining is basically machining irregular shaped surfaces. Contoured surfaces are non-prismatic or planar shapes. Planar shapes or prismatic shapes would be like pockets or boss shapes as an example. Contoured surfaces are surfaces that you may see doing like mold or die work. They're more of a free form type shape. These contoured surfaces require a different approach to machining, and that's what we're going to take a look at today. To illustrate some of the options that we have in NXCAM to machine contoured shapes, we're basically going to program a part that you see here on the screen pretty much from start to finish. We're going to look at cavity mill operation, the rest machining operation, flow cut reference tool operation, Z-level profile operation, and contour area operation. All right, so let's get started at looking at some of the techniques that we use to program this part in NXCAM. As you can see here, I've already got the part open. I'm already in manufacturing. I'm going to look at the machine tool view. I've already got 4 tools created to cut this part. So I've got a diameter 25 R3 cutter, a 16 diameter ball mill, and a 10 millimeter ball mill for semi-finishing, and then a 10 millimeter ball mill for finishing. We take a look at our geometry view. You'll notice that I've already got the part selected, and then I've already have my blank defined. I've defined my blank using the outline option, so this basically outlined the part. So you can see we've got quite a bit of material to remove. So we're going to just kind of imagine that this blank shape that you see here is what we're starting off with. So we've got a lot of material to remove. Our goal is to obviously to reach this final shape of the actual part. So we're going to use quite a bit of different operations to get there. Okay, so the first operation we're going to use is cavity mill. Notice I'm using the contour type instead of mill planar. I'm using mill contour operations. And the first one we'll use here is cavity mill. This does a really good job at roughing out a lot of material quickly. So this is going to take different Z-level moves, step-down Z-level moves, and it's going to remove all the material that it can in each Z-level. So I'm going to use the diameter 25 R3. Geometry is going to be workpiece. And I'm going to set this to mill rough. I want to leave about a millimeter of stock on this part just for roughing. So this is just a good way to get a lot of material away or out of the part in a quick fashion. All right, so inside of cavity mill, I'm going to accept most of the defaults here, and as we go along, I'll change some of these settings and maybe recommend some settings that you might want to change to make things maybe more efficient or better finish on the part. So I'm going to change the cut pattern option here. Notice it defaulted to follow part. I'm just going to use the follow periphery option, and I'm going to change my step down to about 3 millimeters. And I'm going to go ahead and generate. Alright, so you can see this is a pretty good toolpath here. Couple options that we want to change. One of the things that we notice is, like I was saying, this does a really good job of stepping down in Z and then doing multiple passes at that Z level to get rid of that material. So this is based on using a bigger tool to remove large amounts of material. Is what cavity mill is good for. So to begin with, cavity mill is a really good option. What we see here though is, if you notice, these are ramp in moves. Okay, so if I go to verify and play this through, notice that's a ramp in move. We're kind of starting at the inside of this part and then working our way outside. Okay, this is more of a concave shaped part, so that probably isn't going to be the best option for us. We're starting on the inside and then working our way outside. So if this was more of a concave type part, then that would probably be a good option, like a cavity of a mold or something like that. Working away from the inside out would be okay. But since this is more of a convex shape, then we would probably want to use something that goes from the outside towards the inside. Okay, so let's go ahead and change that option. That's going to be in our cutting parameters. Under strategy, notice it's set to outward. We're going to change that to inward and regenerate. Okay, so now let's take a look at the cutter path. You can see it was approaching from the outside and it's going to work its way in. So much more efficient way to cut this, working from the outside, working its way in. So again, we're taking step down moves in Z, but at each Z level we're removing the material, every bit of material that it can remove at each Z level. So we'll let this go ahead and play all the way through and take a look at the result after this is cut. Okay, so we've got a good idea of what this part is actually going to look like after this operation here. So we've removed a lot of that material from our blank stock. We've removed a lot of that material. However, you know, there's at least 1 millimeter of stock on this whole part. And then if you kind of look at the side of this, notice these step shapes here. There's quite a bit of material left on these shapes here. And then also there's a lot of material left in the corners here. If I do a show thickness by color, it's going to illustrate that a little bit better for us. Okay, so we can see the green is a little bit more than 1 millimeter, 1.3, something like that. And then when we get into the blue, it's up to 2 and 3 millimeters. Okay, and I can go ahead and click on certain areas if I want to know exactly how much material is on there. So there is about 1 millimeter. But then if I click on one of these blue areas, notice we have 3 millimeters of material on here. Again, cavity mill does a great job of getting a lot of material out, but it does leave behind some material. So that's what we're going to look at next in the next toolpath, is how to get rid of this material. Okay, so this gives a good idea of how much stock is actually left on this part. So next what I want to do is I'm going to use another operation, and it's called rest machining. Rest machining removes the material that was left behind from a previous operation. It's looking at the IPW, or the in-process workpiece, and it's going to remove the material that was left by a previous operation. So I'm just going to switch this over to the 16 millimeter ball cutter, and I'm going to go ahead and change this to semi-finish. So our goal is to rough this out and then semi-finish and then run a finish operation to it. So that's kind of where we're headed. Alright, so since we're using rest machining, a lot of these options are actually the same. So I'm going to use follow periphery, and I'm going to change my step down and do a little bit less of a step down, and not much else that needs to be changed on this. I'm going to pretty much accept the defaults here. Okay, so what we see here with this part is this is basically what we call a Z-level profile move. When you see right through here, if we remember, there's only a millimeter of material on this vertical surface here, and then like on the top here. So it didn't need to do really any kind of roughing type strategy. So this is basically a Z-level profile move, which is actually what we're going to do here in a little bit for finishing. But if you notice, it does those moves, but it also does roughing moves here. Remember the steps that we had? There's that extra piece of material that was left over. It does roughing moves on those. That's really important, especially depending on the type of material that you're cutting. It's really important to actually rough those out. If we had just done a Z-level move and it hadn't done those step shapes there, then we would have a really good chance that the tool may break or may end up with a bad finish or something like that. So it's a good idea to go ahead and rough these shapes out using rest machining. All right, so let's take a look at this tool path and see how this actually cuts. So again, you can see the IPW, the in-process workpiece that it's starting out with. We cut the top of the shape here, and then starts working its way down the sides. I'll go ahead and speed this through, and then we'll kind of take a closer look once it gets down to these step areas. Okay. So now let's take a closer look. Notice there, it's taking a extra cut to rough out that step shape. And then it's going back in and going around the outside in a Z-level profile style path. So this is a really good way, really good option to use rest machining so that it will actually kind of combine roughing strategies and a Z-level type operation all within one operation and referencing what has already been cut. So a good, efficient way to do things here. So we can see it's cutting out those step shapes and then leaving a pretty good finish for a semi-finish operation. It's leaving a pretty good finish as well. So I'll go ahead and speed this up so we can go ahead and go through, and we'll take a look at our show thickness by color to see what we actually have left here. Okay, and we'll do a show thickness by color. All right, so again we see the green area. This is about 0.3 left on this, which is what we have set for our semi-finish. So that looks pretty good. So if I pick around here on the outside, we're about 0.3 away. This is pretty much what we want. Right, but if you notice the blue area through here and even some purple in here, we actually have quite a bit of material in these corners. Reason for that is we use a diameter 16 cutter. Okay, these corners are a lot smaller than that, so it didn't remove quite enough material. But we did a really good job of finishing pretty much everything else. We have a little bit of blue shape across here, but I don't think that's really a problem since that's more on a flat shape. But this could be a problem here. If we were to run our finish cut right now, you could have some problems with chatter and things like that, or even some tool breakage if you went down in this corner here with the finish tool. So what we need to do is we need to cut these corners out of here. Okay, we can see the blue, a lot of extra material left in there. And so what we're going to do next is we're going to use a flow cut with reference tool. Okay, flow cut with reference tool. We're basically going to use a diameter 10 ball mill, and we're going to reference that diameter 16 cutter that we just used. I'm going to change this to my semi-finish diameter 10. We're going to leave this set to mill semi-finish. Right, and we're going to go into our drive method flow cut. we're going to go into the settings. A lot of different options that we have in here of how we want to cut corners. Okay, again, flow cut is used for cutting corners, and corners left, in this case, left behind by a reference tool. Okay, you can limit this with a steep containment. We have steep and non-steep cutting areas, and then we actually have options for both if you want to cut those in a different type of strategy. And then our steep containment, you can limit that in a different angle. Okay, so an example of a non-steep area is going to be this corner here where my cursor is. And then a steep area is going to be like this vertical type shape here. And that's broken up at 65 degrees. Okay, so we're going to go ahead and leave the 65 degrees. Notice this is set, the non-steep areas are set to zigzag, so that would maybe come around through here and then go back. That's going to be climb and conventional cutting. That's not the condition that we want. So what I want to do on this is I want to actually do just a zig pattern, and then I'm going to set it to climb cut. Okay, so I want it to climb cut the material. Right, and then notice that this is set from outside to in, and it's going to alternate from outside to in. That means the cutter is going to come up through here, the top portion of this corner, and then come down at the bottom and work its way towards the inside of the corner. That's a really good way to do things, because if this was not doing it that way, you could have a chance that the cutter would be coming straight into here and taking a pretty heavy cut right in the middle of that corner. So it's always a good idea to work your way from the outside to the end of a corner when you're roughing out larger amounts of material. Okay, for our steep cutting, we're going to do a cross-cut zig. Cross-cut zig will actually do Z-level moves and work its way down from the high to the low, which means from the top to the bottom, in separate Z-level moves. So it's really a good way to do that. I'm going to go ahead and accept the defaults there. Next thing we'll look at in this dialog is reference tool. We need to tell it what tool to reference. Okay, we used the 16 ball cutter just a second ago. That was the last tool that went in here, so we just simply select the 16 ball cutter. Now overlap distance. This is going to look at the material that was left behind by the 16 millimeter ball, and it's going to overlap or start outside and continue on past by 1 millimeter from what stock was left by the 16 millimeter cutter. I'm going to bump that up a little bit. I like to kind of overlap these a little bit, so I'm going to change that to about 3 millimeters. All right, and I'm going to go ahead and generate. So you can kind of see the boundaries here, and it's picking out the corners as it calculates here. All right, and I'm going to change one thing. I'm going to change our arc moves and non-cutting moves. I'm going to make those a little bit smaller so we can see a little bit better detail of what this path looks like. I'm going to change that to about 30% of the tool diameter. And generate there. So now you see those look a little bit better. Okay, so again, here's our steep areas that steps down in Z. And then here's our non-steep areas. And this is going to work its way from the outside in. We'll go ahead and run verification on that so you can see a little bit better how that's actually cutting. So this is our goal here, is to get rid of these corners. Remember how those were blue and had extra material in there? We want to get those down to about 0.3 stock so that when our finish cutter goes in, it's only removing about 0.3 material. Okay, so you can see that this is a non-steep area, and it's working its way from the outside into the middle of that corner. Okay, now it's onto a steep area. You cut the steep area in this vertical type shaped corner here, and then working its way from the outside to the end. And I'll go ahead and speed this up Alright, so we can see the yellow area is the area that was just cut. That's looking pretty good. Let's take a look at show thickness by color and see how much material we have left in those corners. That looks really good. So I'm going to go ahead and pick a couple areas in here. About 0.3 material. Okay, that's what we want to see before we go on to our finish cutting operation. Alright, so now we're ready to finish this part. What I'm going to use to finish this is a Z-level profile. Okay, and I'm going to switch over to my finish tool, the diameter 10, and I'm going to switch to finish cut method. Alright, and I'm going to accept most of the defaults here. I'm going to change my step down to about 0.5. That should give us a pretty good finish there. I'm going to go ahead and generate this. Alright, now here's my Z-level operation. Notice we don't get the shallow areas with the Z-level profile. Okay, but it does a really good job of getting these vertical areas. Okay, one thing we may notice is we have arc-in moves, and then each time it goes to the next arc-in move or the next step down, it goes up to the rapid plane. Okay, that's set up in non-cutting moves. So if I want to save a little bit of time and not allow the tool to come up to that rapid plane, I can simply just go into non-cutting moves, into our transfer rapid tab, and then I'm going to use lowest safe C for our between regions. And notice now it goes directly to the next arc-in move. So that may save a little bit of time. A couple other options that we have here for our lead in and lead out moves, depending on what type of finish you need and things like that. A couple other options that I like to use are under our connections tab. Notice this is using the transfer method that we defined in non-cutting moves. We can actually use a direct on part. Okay, and that goes directly down from one step down to the next, directly onto the part. Okay, so depending on the type of finish you need, that may be a good option. Then we also can ramp on the part, and we can set a ramp angle here. So I'm just going to leave it set to the default, and notice it ramps, does a real small ramp in move down to the next level. And then the last option is stagger ramp on part. This is going to give you kind of a staggered or spiraled type shape. So it goes from one connection move down to the next in a spiral type pattern. So that looks pretty good there. Again, depends on the type of finish that you need on your part. One other thing that you notice that this is cutting all the way down this surface. If you remember, our blank was defined as this shape already being cut. So if we want to limit that, we can go into cutting parameters, containment, and we can trim this. Notice the tooltips that come up here. Notice it's cutting all the way around that part. If we trim this to silhouette, it will get rid of the outside shapes here. And it's going to tell me that some of the transfer methods we can't use because we have some open areas here. So that's fine. And okay, so now we have that trimmed basically. So it's not doing the extra cutting moves down towards the end of this, the bottom portion of this, since we've already got that cut. Okay, so now we need to address these shallow areas. There's a couple different ways that we can do that. We can actually do that within the Z-level profile operation. So let's take a look at that. That's going to be in cutting parameters. Under connections, we can actually cut between levels. Okay, we can set our step down a couple different ways. I'm going to use the same step down as the depth of cut, which was the 0.5. So I'm going to go ahead and accept that and generate that and take a look and see what we get here. Okay, so now you see that it adds in moves in between these Z-level moves where we had probably a lot rougher finish. It actually adds in moves there for us. Notice at the top here, does a really good job of finishing the top of this as well. It added in these moves around here down towards the bottom. So all within Z-level profile, you can actually get a good Z-level finish and then a really good non-steep area finish as well. If you need a different cut pattern than this, then it's probably a good idea to go ahead and do a different operation. So that's what we'll do. So I'm going to switch this back to not cut between the levels. Okay. And then what I'm going to use is a contour area operation. Okay, we're going to use the same cutter, same finish method. Alright, so what I'm going to do in here is in our drive method options, we have different cut pattern options. We have a zigzag option and for non-steep cutting, and actually that's all we want to do. I'm not going to waste the time of cutting these steep areas, so I'm going to set this to non-steep. That's all I want to cut is the non-steep areas of this part. Okay, I'm going to go ahead and just leave it set to zigzag and take a look at the cutter path that we get. Okay, obviously I need to change my step over, but we get a zigzag type operation, and you notice is the zigzag pattern kind of goes across here at an angle and then directly 90 degrees to the way that this surface runs, so that may not be really the best option for us. Okay, on this part, this isn't something that I use really often, but a radial zigzag on this part actually works pretty good. So I'm going to select, this is basically a radial type pattern, and I'm going to select the center as the 0, and then I'm going to change my step over to a constant step over of 0.5 just to match what we used on the constant Z profile. And I'm going to go ahead and generate this. So notice that this part is actually more of a cylindrical type part, so this radial zigzag operation actually works really nice on this part. If I look at this from the top view, notice it works from the center, that 0 point that I had selected, and works its way out. So these cuts actually go along this surface. So if I spin it around, you'll see that this has kind of an even flow across these surfaces. So that actually would probably give a really good finish. Alright, so we've cut this part pretty much complete from start to finish. We did a lot of different options, a lot of different roughing options, semi-finish, and finishing options. That's all we have the time for in this session of Lunch Bites. I want to thank you for attending. I hope this session was informative for you that maybe haven't done this type of machining before, or maybe those of you that are familiar with this type of contour surfaces. I hope you were able to maybe pick up on some tips or different methods along the way. If you have any questions about today's session, you can email those to me at chad.varney@allyplm.com. I also want to encourage you to go to our website at www.allyplm.com and check out our current NX training options. We offer a 1-week Essentials for NX Designers class. We also offer a 1-week NX CAM Fundamentals class. We also offer a 2-day NX Turning Fundamentals class. We offer those classes here at Cincinnati, Ohio location or online. I want to thank you for joining us. Hope you have a great day.